Hello everybody, this is a fifth week lecture on machine vision. Today we will learn how to handle OpenCV data. This lecture consists of two parts. One is an overview of OpenCV program and the other is on handling metadata. Overview of OpenCV program includes the basic OpenCV structure and such as a point and rectangle, and second one is OpenCV met data that handles the image data, and third, the explanation on image type and pixel type, and the image input and output, and drawing stuff such as drawing circles or rectangles above the input image. And the fifth, using the mouse in OpenCV program and converting color space between different color standard such as RGB and HSI type, and image normalization, thresholding, edge detection, smoothing. These kinds are the digital image processing stuff. And we will learn the linear algebra, including singular value decomposition and the principal component analysis. Singular value decomposition is used to solve the linear equation ax equals b. So in order to solve this answer, we need to calculate A inverse. So when the A matrix is a very large matrix, we need to use a singular value decomposition. The principal component analysis is to calculate eigenvalue and eigenvector from some matrix. And second part, the data metadata part, we will learn 5 ways to handle the metadata. The first, met method, and met row and column method, and met pointer method, and met iterator, and low level point operator. So we need to select one of these method to handle the metadata. Let's start overview of OpenCV program. There are structures used in OpenCV. Because we use C++ in our lecture, it is actually class, C++ class. So we will start the point, size, rect that contains a rectangular object, and the rotated rect, so we contains a rectangular information and the angle information, and the mat contains the image data. So this is a very important structure. So first, there is a point class. It contains x and y coordinate of 2D point. So in this class, there are some functions that are included in the point class. One is dot point. So if we have a point dot b, so we will calculate dot product between a and b point, and point dot inside and rect object. So if there is a rectangle object and then when we give the rectangle object here and the point is here, so we can check whether point is inside of the rectangle or not. So it returns true if point is inside. The point class also offer math operators. You may use a point operator plus and plus equal, minus, minus equal, multiplication, multiplication equal, and we can check whether A and B are the same point or not, and not same. So these are operators. So we can calculate the point class. It is very similarly to the some calculation between some numbers. A plus B, 3 plus 2 equal 5. For example, so even though it is not a number, it is a point class. We can calculate this point class exactly the same way of calculating numbers. Here is some example code. So we define the point A 1, 1 and point B 2, 2. So that means actually it is here is a 1, 1. This is A point, and 2, 2. This is point 2, point B. So point C equal A plus B. This is a plus point operator. So by using point operator, we calculate C. That means it is 1, 1 plus 2, 2 means it is 3, 3. So C out C dot X comma C dot Y. So the result is 3, 3, and by multiplying A by 2, and so the answer is 2, 2. A was 1, 1. So by since we multiply 2 to A, so we get the 2, 2. So we print out C X, Y, so we can get the 2, 2. C out is normalized B. So it is normalized B. That is root square plus 2 square. So 2 root 2. So root 2 equal 1 point. So by calculating this number, so that is answer. So normalization is B calculating the size of B. So this is length from here to here. This is B normalization, and so if A equal B, so A B is different, so we cannot print out this one. Instead, because A B is not equal, we will print out this one. So we get this result, and the B is not same as C. Currently C value is 2, 2, and B is 2, 2. So it is wrong. So we print out this C out sentence. So this is the output of this program. So this is the way to declare the point A and B, and this is usage of the operator. plus operator, and we can calculate many operation using this operator. So it is very easy way to use this point class. There are size and length class in OpenCV. Size class have its width and height information of the image. So if image is like this and the width and height, so size dot width and the size dot h will return the width and height of the image, and functions included in the size class is a dot area. It returns width dot height value. This is the area of the triangle, the rectangle, and the rect contains the rectangle information. In order to define the rectangle, so this is a point left top corner x comma y, and this is width and height. So we can define the rectangle. So the function inside of the rectangle class is a dot TL top left point and the BR bottom right point. So we can access these two information using this function. The CMAT, the primary data structure in OpenCV is a mat object. It stores images and their components. So main item includes row and column, the length and the width of the image. So row is, this is row, and the number of row, and this is column. This is number of column. So row by column is a traditional way to express the images. For example, and the channel, there are channel 1 is a grayscale, channel 3 is a BGR color. So in order to express grayscale image, we can have only one image data, but if we use a BGR, so we should have 3 channel that contains blue, green, red images. So depth of the pixel image is a CV depth. C means this is channel, and this part represents the depth. So this is example. Integer main, integer argc, comma r character star argv. So this is argument count and argument value. So if you have for example, you create some executable file ex1, so that is exe is the executable file. When you run this executable file ex1, and you can type in some input file name, or in this case there is some image name, Lena. So in that case, and 2 for example, so the argc argument count is 1, 2, 3. So argument count is 3. Argument value is array that has ex1 lena.jpg, and 2, this is a argv. So argv0 is ex1, argv1 equal lena 2 equal 2. So this is what argc and argv means. So here is a lena.jpg here. So this is the name of the image, argv1. So this is a string of image name, and the image will read that image file, and it return to the image. That is a met class. So once met class is created, we can access the column information using image.cars, and image.row returns row information, and the type image.type will return the type of the image. So type CV is prefix for the type computer vision, and 8 is 8U means 8-bit unsigned integer. So 256, that means we can express the intensity from 0 to 255. So 8-bit unsigned integer, and the channel is 1. That is, it is a grayscale image. So type is equal to this type. Then we will print out CV8UC1. Then this 8UC3 means it is a color image. There are three channels for BGR. 32FC1 is a 32-bit float point number. So there is a channel is 1, and there is a grayscale image. And this 32FC3 means it is a color image with the 32 float point number. So it is output of this program. This column is 400, number of row is 300, and the type is CV8C3. That is a 8-bit color image. So this image is 300 by 400. So this is a row is 300 and column is 400. This slide shows the functions that met class offers. So met.add, this is a data type, and the row and column and channel. So if we have a color image, there are 3 channels, and when we access row and column at this point, then it returns point to image location. So we will access this number that is saved at the R, C location, and we can cast the data type here. Then we can receive this number to our program. So met.channel returns the number of channel. 1 is grayscale, and 3 is color RGB, BGR. And that clone, it returns a deep copy of image. If we have a image, and met.clone will copy of a image. And met.create, it create a new matrix, row, column, type, and the dot cross computes cross product of two matrices. So we input the matrix here. When we declare mat A and mat B, so in order to cross product A cross product B, so we call A dot cross B. It returns the cross product value, and it is a dot A dot B. It returns a dot product, and the depth it returns data type of the matrix. It is another mat functions. So when we have image like this is a source image, this is x-axis, here is a y-axis, and when we define the x range and the y range, so if we define x minimum, x maximum, and y minimum, y maximum, then we can define these sub images. So if we send a command like this, mat range x min, x max, and x range y min, y max, it returns the sub images. And mat.type returns a type of matrix 8UC1 like this. So iterator usage. Iterator means when we do the similar action, we are iterating similar action on the image, we use iterator. So this example is example of using iterator to convert an image. Converting image means if we have some grayscale image, this is black and this is black, this is white, so we inverting this is a black, white become black, and the black become white. So we can get this image by subtracting this is white minus this pixel value. So when white, that means 255 become 0, and black means 0, so black becomes 255, and some gray scale, for example here is a gray level 180, 255 minus 180 becomes 85, something like that, 75, 75. Okay, so mat.begin moves mat iterator to beginning of the image. Mat.end moves mat iterator to end of image. So when we do this thing repeatedly, we move the pointer to certain pixels. So mat.begin moves the pointer at the beginning of the image. Mat.end move this point to the end of the image. So in order to inverting this image, this is original image. So we do not change the value of original image. So we define the met constant. So that means we will not change the value of this image. Iterator. So that means this is original image, and the pointer is a source underbar it equal image begin. The unsigned character, these two are the same character type, same type, and another met constant iterator, source it end underbar end. So this is image dot end. Met iterator, it does not have a constant. That means this is a new image that will be created in these actions. Met iterator, unsigned character, destination underbar it. This is a variable, and return dot begin. Return the image that begin. So it is a starting point of this inverted image. So for source it underbar it, source it is not source it end until it is not source it end. The source it plus plus and source it, destination it plus plus. So we increase the pixel point, then the source, this is source, and this is a destination image. We also increase the point. Then pix equal source it. So they read that contents of at this address. That is a pix. Then destination it's contents equal 255 minus pix. So we invert that image and save the as a destination image contents. So that is iterator usage of met. This slide explains the image types. The type is a very important aspect of OpenCV, represented as CV, data type, and C, number of channel. So we already studied this CV8U in the previous example code. That is 8-bit unsigned integer. 8s is a signed integer. 16u is unsigned 16-bit unsigned integer, 16-bit signed integer. 32f means a 32-bit floating point number. 64f means a 64-bit floating point number. The pixel types shows how the image is represented in data. So BGR, that is blue, green, red. OpenCV use BGR pixel types. So ordinarily we usually use the RGB, red, green, blue. So this order, but in OpenCV we use BGR. So BGR is the default color of IMRead. That is a command that reads the image, and normal 3-channel color. So this is our BGR 3 channel. There are 3 channel, and another pixel type is HSV. H means hue. Hue is color, and S means saturation, is amount. Value is lightness. So there is a 3 channel. So we can switch from here to here and here to here. So OpenCV provide these pixel type switchers. And another type is grayscale. Grayscale, this is a single channel. We usually use 0 to 255 as an intensity. OpenCV requires that the image to be BGR or grayscale in order to be shown or saved. Otherwise, undesired effects may appear. So this is a BGR color image, and this is grayscale. This is example code of OpenCV. It reads cats.jpg and displays it on the monitor using OpenCV. They included cv.h, cv auxiliary.h. High GUI, it deals with the windowing, making a window using namespace cv. If you don't define this line, you should write the cv dot. So you repeatedly cv colon to define the namespace. But when you are using namespace cv here, then you don't need to write the namespace every time you call the OpenCV subroutine. So this is main function, and argc and argv. In here, argc is 1, 2, 2, and argv1 is cat.jpg. So it reads cats.jpg image, and they create mat class, and the name of that class is image. So it create a window. The name of a window is a sample window, and IM show is image shows. So sample window image. So they create a sample window here, and it shows cats.jpg on this window. Wait key 0 means it wait some input such as button press or mouse press. So it waits infinitely for the input. If there is some number here, wait key 10, then that they wait 10 seconds. Then automatically it run the next command. So this is the first example. As we can see in the previous Hello World example code, so OpenCV used the CB namespace, and CB object replaces the original C standard IPL IMAGE. I think this is image processing library image. And the CB these two are used in old version OpenCV. And so the met is replace these two old version classes, and all original functions and the classes of a C standard OpenCV component in Bredsky book are still available and current. However, you will need to read that book for it. Named window is used for viewing image. In general, default string as input with original image size set. Else, use string as input name and 0 for adjustable size. This slide shows image input and output. OpenCV provides a simple and useful way to read and write image. In reading image, we already met imRead command. This is a string. This is a name of info file. And the next parameter is 0 for gray scale image and 1 for BGR color image. So if we do not write this option, OpenCV think you select number 1, the color image. So 1 is default. That means you don't need to write 1 here when you use when you read the color image. When you read the gray image, you need to write the file name and the 0. That is a gray image. They will read gray image. And imWrite is writing an image. So this is a file name and the image that will be write in. And named window is create a window for output. So imShow is for output image to window. And window name, so this should be the same. And image met to show, so image file. So we already met the wait key 0 here. Here, wait key integer x has two main features. If x is greater than 0, that means it has some numbers. Then wait key will wait x milliseconds. It's if you write 10, that means 10 milliseconds. That means 0.01 second millimeter. 10 and if x equals 0, then the wait key will not move until keys are pressed. So it will wait for your key input. Sometimes it is necessary to draw stuff on the image. Instead of using complicated function, why not just call a simple function? Here are some simple examples. Here is a void circle, and it will draw circle on the image. So this is the name of image that we will draw on, and the point is center. This is point x comma y. This is x. Here is y. And in this radian, that means it is angle from here to here. And it defined the color BGR. So by setting the proper number, we can set the color. And the thickness of the line, this is for example, it is thickness is 1, but you can increase 2 or 3 the bigger thickness. And ellipse is the same format, but it uses rotated rectangle. That means if you have image here, this is a rotated rectangle, the width and height and angle. So you can define the rectangle using the you can define the ellipse using the rotated rectangle box. Then you set the color and the thickness. The line is a point, starting point and end point, and color and the thickness. Void rectangle, so point, 2 points, so you can define the starting point and the ending point, left top point and the right bottom. Then you can create rectangle. Note the negative thickness will fill in the rectangle. So if you have a -1, then it will fill a rectangle. This program is a sample program for drawing stuff. So you can see the output image on the right top. And the first one is matte image 300. So this is 300 by 300 image. This is a color image, and another matte image is sub image read arg1. So we receive the input image file and make a sub image. So we don't know how big is it. I think this is a Waldo image. We define the X and Y. The project image on to new with 45-degree rotation. So this is a rotation matrix. We have X and Y, and IJ is input image. We in order to rotate 45 degree, cosine 45, minus sine 45, sine 45, cosine 45. So cosine 45 is 1 root 2, so this is 45. Cosine 45 is root 2 over 1, and that is 2 root 2, and it is 0.85398. So this matrix is actually 0.8539 minus 0.8539, 0.8539, 0.8539. So x equal this plus this, and the y equal this one. So we can get these two rotation image. This is x and y is a new rotated image coordinate. So here we access to the original image ij sub dot at, means we access this value at I comma j. The type is a vector 3b. Then we copy this one to, we switch ij with y and x, and we y plus 30 comma x plus 90. So we copy this image to the rotated image of rotated position. Okay, so image is the original 300 by 300 image, and after calculating x and y, and they plus x plus 90 and y plus 30, and they switch x and y position, then put the image. So this is a wild image of 45-degree rotated, and they switch translate along 90 and along x, and yeah, here is x axis and here is a y axis. So we translate 30 to x direction, and we translate 90 to y direction. So here is a Waldo image. Next step is drawing an ellipse. In order to define the ellipse, we need to define the rotated rect first. So here is a rotated rect. This is the center of rotation, and this is size of rect. This is angle. So center x 100 and y equal to 20, about around here. Here is x rotation center, and the size equal x size equal 90 and y equal 170, and this center is 100,20. Then we rotate 101 degree, so we rotate around here. So finally we get this rotated rectangle. After we define the rotated rect like this, then we create an ellipse based on the rotated rect. Here is a rotated rect, and the scalar, this is setting the color. This is for setting the color. This is B, G, R. That means we set the color red, and the thickness is 3. So this is a rotated rect, and here is rotation center. The next step is drawing a circle. Here is circle command, and this is center of the point. X equal 240 from here to here. 240. Here is a 200. This is the y-axis. Here is the x-axis. Okay, see, this is the center of the circle, and 25 is radius, and the color is blue, and the -1 is we will fill this circle inside. Next step is draw a box. We use the rectangle command. Point means left top point is 30,190. The x from here to here is 30, and from here to here is 190. and here is a right bottom corner is this point, and color is BGR. This is green color, and thickness is 1. And we can also place a text. Put text. Where is Waldo? This is the text we want to write on, and the point 10, 100. So x is 110. From here to here is 150, and the font that we use is a font underbar Hirsch Simple Lex. So we can use this font in OpenCV, and one is thickness, and Scholar is set the color BGR. This is the red color. So after we draw everything, we can output this result. So we use I am right. So image0.jpg is the file name, and we output our image to the input image.jpg file. OpenCV allows you to use a mouse to interact with the screen. Note that this feature is from OpenCV 1.0 and is compatible with a math object. So this program allows you to draw a dot on the image. Here is a structure options here. Option, this is a constructor of this option. So when we call option structure, we clear the set the initial state x equal -1, y equal -1, and drawing dot set false. The false drawing dot is a Boolean Boolean variable. This is in option structure. There is a x, y. This is a location of a dot, and Boolean variable is a drawing dot. It is a when drawing dot is true, they draw the circle, and if drawing dot is false, they don't. So we declare the options. They use the same name option. So option is option structure. Okay, let's look at the main function. So they load image. They use IPL image, the old-fashioned image structure, and they read that image using CB load image, and they create a math frame image read. So they create the image and the frame, 2 images. They create a window named Wyatt. CB set mouse callback Wyatt, my mouse callback, and void image. So they check the mouse callback. So they check the input from the mouse while the Wyatt inside of a Wyatt window, and when there is some actions, they call this program my mouse callback, and they do something on this image. Let's go back to mouse callback. So integer, event, x, y, and flag, and parameter. So this x and y is mouse location, and there are several events. For example, left mouse button, right mouse button, center mouse button, left mouse up, right mouse up, something like that. There are several events. So they use a switch command, and they check the event.
in case of a CV event, left button down. So when user press the left button, then they read that location X and Y, and they switch the option dot drawing dot equal true. So when they press the left button, they want to draw a dot at that position. So after we call the CV set mouse callback here, then they use a while command. CV wait key 15. That means they wait 15 millisecond and check the keyboard input. So when keyboard input is not 27, that means 27 is escape button. So they do not press escape button. They keep doing this one. So that means when you exit this while command, then you should press escape button. If option dot drawing dot, that means it is true. That means they press the left button, then circle. They draw a circle. Position is option dot x and option dot y. We already save this location here. And the 3 is the radius, and the color is blue, green. So blue and green is 255. That means it is a yellow. And the 2 is the thickness of the circle. And they reset the option drawing dot equal false. So the image show wireframe. So they show that the result, and the wait key 10 seconds. And when we press the escape button, they stop doing this. And the CV release image, so we can finally so this is old-fashioned way to make image and destroy image. So but in math command, we don't need to release the frame memory, but in old-fashioned one, when we create image, we should destroy that image memory. This is a result of that previous program. So there is many dots here, and the thickness is 3 and the radius is 5. So the wire is name of the window.
This slide is for explanation on the converting color space. We use CVT color, converting color command when we converting color space. This is input image. This is output image. This is code. There are 3 code here. This is for example. Code consists of CV underbar color space to color space. This is current color space and the destination color space. So CV BGR to gray, BGR color space to grayscale color space. This is not color space, this is grayscale. CV underbar BGR to HSV, hue saturation value color space, and the CV BGR to LUV. So I will explain what is LUV and what is HSV and what is the VGR. First, VGR color space consists of three colors: blue, red, and green. So there are three axes. So this axis, this position is B equal 1, 0, 0, or 255, 0, 0. This is the same meaning. This is blue, red, the green. Okay, so the yellow is blue, green, and red. This is yellow, and the cyan is B. This cyan, blue and green. The magenta is 1, 0, 1. White is all components are full. So 1, 1, 1 is white. Black is 0 and 0 and 0. From 0, 0, 0 to 1, 1, 1, this is a grayscale image. Okay. So the three components are exactly same, but we can express only one number to locate this position. There are complementary color. So cyan is opposite of red. So 1 minus red is cyan. And the magenta is opposite color of green. So 1 minus green is magenta. Yellow is opposite color of the blue. So opposite color is a complementary color. And the brightness of a BGR system, so we can calculate the brightness using this formula. The LUV color space is L means luminance, and the U and V are some coordinate. This is a U axis and the V axis is here, and so it is very complicated. It is very difficult to understand, but the scientists on the color create this graph, and BGR to LUV, we use this formula to converting BGR to LUV. Yeah, LUV is the exactly same name of a YUV. Yeah, this is LUV, luminance. And LUV to BGR, we use this. Another color space is HSV. This is hue, saturation, value. Another name of HSV is HSI. This is intensity. So they use three channel. One is a hue channel, the color channel, and the saturation channel. Saturation is related to how the color is clear, and intensity is brightness of that color. So let's look at this graph. So here is a circle. This circle is this image. You can see here is a red, yellow, green, cyan, blue, magenta, and from center, as we approach to the edge of this circle, the hue increased, and when we rotate uh, this clockwise counterclockwise, we can change the hue. So that this circle express hue and saturation in one circle, and as intensity increase, the total area become brighter, and the area becomes smaller and smaller, and when intensity is maximum, that means when it become white, there is no color, and all area become 1 point, and this is white. And as intensity decrease, so the final destination is the black. It is a point, and there's no area, and so it has a zero value. So this is geometric expression of the HSV color space. This slide is for image normalization. So the typical usage of image normalization is use normalize subroutine. This is input image, and this is output image, and low, high, this is a range, and the method is for normalization method. So image normalization is the process of stretching the range of image from A to B to C to D. So when you recall the histogram of an image, this axis is population, this axis is intensity, and intensity varies from 0 to 255. An image have some population from here to here, A to B. So because it does not use the whole range of the intensity, it is a very dark image. So image normalization make this image use broader range C to D, then it is normalized like this. Actually, when we modify the image, and sometimes the result of calculation is beyond 255 or below 0, then makes very big problem, and they truncate, and from here to here, so we truncate the information here, so we can only use from 0 to 255, so we will lose information that is in this range. So this example code is for normalizing the result of a Sobel edge detector, and this is original grayscale image, and they detect the edge of this baby's face using Sobel edge detector. So this is a result, but when we normalize this image, then we can get the more intense and balanced image, so we can see the edge more easily. So let's look at that example code. There is include files cb.h, cbauxiliary.h, hi GUI, and IOStream. they use namespace CV and the standard, and they create mat image by reading the input image. arg1 has a name of the input image. I think this baby's face picture, and the 0 means that is a grayscale image, and they create mat pointer, but they do not assign the memory, so they just create data dx dy mat pointer, and the float picks. So when this code read the input image and it write image 0.jpg and it copied the image, and the image that convert to data CV32FC1. So I think this image have unsigned 8 unsigned this type, but they convert it to the float 32-bit float image, because we want to calculate something. So integer is not good for the calculation, so we convert the integer format to the 32 float point number. So they multiply data 4 times. They make data 4 times. Then they make a Sobel edge detector. So if this adjacent pixel has this intensity change, they create linear difference, intensity I plus 1 minus intensity I. So this is the 1 pixel, so divided by 1, so it is a linear intensity. So this is input image, and the output image is dx, derivative to x direction, and CV32FC1 is a data type, and this is x direction derivative, and the y direction derivative is 0. So the same method, by the same method, they create a y direction Sobel edge detector. So here the y equal 1, x equal 0. So when we have an image like this is x-axis, here is a y-axis. So we make a x direction derivative and save the dx image, and we create a y direction derivative, and we save the image to dy. Met constant iterator is used to do a similar thing to the image file. So met constant means we will not change the contents of the original image, and this is the type float dxit equal dx begin. So it returned the beginning position of the image, and dxit end is assigned to dx end, and here is another dyit equal dy dot begin, and the destination it is data that begins. So this is destination, and dx dy are source. So the for loop is start beginning, and dxit is not dxit end. So before dxit reach to the dxit end, they keep doing this routine. And at that time, the destination it is increased, dxit is increased, and dy it is increased. So we calculated delta x, delta y before. So we create delta x square plus delta y square. So this is the total derivative of intensity by Sobel. So data, the destination is data that converted to so CV UC1. So we convert the data into image. So image has CVU C1 is a grayscale image and 8-bit unsigned integer. So we write this image to image 1.jpg, and we normalize this data. This is input and this is output, and we set the range. So we set ranges from 0 to 255. We will use a full range of the intensity. So CV min max is the method to normalization. So when we select CV min max, this is a minimum intensity and this is a maximum intensity. So we don't know how what is the range of the intensity in image. So we don't know, for example, like this. So by normalizing this data, so we can use a whole range of the intensity. So this data is inverted to the 8-bit unsigned integer. So it is saved to image 2. So image 1, and this is image 2. So this is a result of normalization. So we can see more clearly over here. So it is a benefit of normalization. This slide explained on the thresholding. To do the threshold, we need to call the threshold subroutine. This is input image, this is output image, this is a threshold value, and the maximum value that each pixel can have. There is some code. Code is a method of thresholding. Different action will be taken depending on this code. There are 5 code here. Threshold binary. So if we have some this kind of image, actually we deal with the histogram. This is intensity. This was a population. So we can have a threshold value here. Threshold. Oh. So this can be 255 white and this can be 0 black. So we can do the thresholding in the histogram. like this. But in here is intensity. This is x-axis or y-axis. So the pixel location here, and intensity varies from 0 to 255. So the threshold binary means if we set the threshold value, this one here, so the pixels that has a value above the threshold become maximum value. So this is we can set the maximum value, so this become this, and otherwise it become 0 maximum value, 0 maximum value. That is a threshold binary. And the threshold binary inverse means inverse means when the value is less than threshold, it become maximum value, and it is above the threshold value, it is become 0. This is inverse. And the threshold truncation. Threshold truncate is, so if it is a threshold value, and if the pixel that has a value above the threshold value, it is truncated like this. So final value is if the pixel has a value less than threshold, it has its original value, and pixel value that has above the threshold, it is a truncate to the threshold value, and it has original value, and it has truncated the threshold value. This is output of this threshold truncate. Threshold to 0 is if value is greater than threshold, it has its original value, and it is less than threshold value, it becomes 0 original 0. This slide explains on the edge detection. There are Sobel edge detection and scar edge detection, Laplacian edge detection. Sobel and scar is 1 degree of derivative edge detector. For example, if there is some difference between intensity of adjacent pixel, I plus 1, then we calculate the slope of this value. So this is a plus slope, and if there is some decrease in the intensity, we will get the minus slope of the slope in the edge detection. So Sobel edge detector, here is image, input image and output image, image depth, and dx dy. So x direction or y direction, we need to select the direction of the edge detections. And the SCAR edge detector has the similar approach and the format as the Sobel edge detector. Laplacian edge detector is a second derivative of the intensity. So that is this is delta x delta y. So actually it is delta intensity delta x, and this is x direction Sobel edge detector, and delta I delta y is y dy y direction edge detector. So Laplacian edge detection take input image, and this is output image, and the CB depth image. So Laplacian is delta square I delta x square delta I square delta y square. This is the second derivative of intensity. So let's look at the sample program. So there is include file, and they use namespace CV, and in this example program, they read the photo.jpg. This is a input file, and 0 means a grayscale image. It read image, and it assigned image mat, this mat file, and the image write, so it copy to the photo gray.jpg, and mat image float. So before we apply the edge detection subroutine, we need to convert unsigned integer format to the float format, because we need to calculate complicated calculation. So we, in that case, we should use a float type. So Sobel input image is IMFL, this input, and this is output, the same image name and the data type, and this is a y direction Sobel edge detection. So this way, this is y direction, this is x direction. So because they take a y direction Sobel edge detection, so this edge is greater than this edge. Okay, this is x direction edge, and this is y direction edge. So after they take the image float, this is output of Sobel edge detection, then we create another mat file, image abs absolute. So we take absolute of image float. So for example, image float have there can be plus edges and minus edge, and plus edge and minus edge. It is image float, and by taking the absolute to the image float, this is plus is remain same, but the minus part become plus. So this, it is a ABS image float. So we normalize this image. When we normalize this image, so we normalize the minus value become 0 and plus maximum become 255. So this image can be normalized like this. But when we normalize the absolute image float, then this is 0 and 255, 0, 255. So this normalized image is here. So so many pixels has some gray pixel and some positive pixel has the bright image, and some negative image, the edge has the dark image. So this is a image float image, and when we see the absolute image float, that is a normalized image, is like this. The many pixel has a 0 pixel, so it is a dark base background, and the bright edges, we can see the bright edges. So this is a output. So this image is better to see the edge information. Image smoothing is used to reduce the sharpness of the edges and the details in an image. Why we want to reduce the sharpness of the edges? Actually, there are some noises here. So it black and white noise over this picture. So it is a very sharp edge between the noise and the original image. So by applying image smoothing, we can eliminate these noises. So that is the main purpose of applying image smoothing. OpenCV includes most of commonly used method. So the Gaussian blur and the median blur. Actually, you need to understand the convolution mask to understand the image smoothing. This is a This is a 3x3 convolution mask, and it has its own weighting factor for each mask. For example, it is 9/1. By summing all the weighting factor of the 3x3 convolution mask, sigma mij equal 1. So in this case, there are 9 member of a mask, and there are 9 weighting factor. So summation of all weighting factor of this convolution mask is 1. This is a requirement for the convolution mask. This mask is applied to the original image. For example, at here, so by applying this mask to here, there is a intensity of the original image. So we multiply this weighting factor to original image. So Mij, Iij, so Mij equal 1. So by multiplying this weighting factor to original image, we'll create one number. So we assign that number to this intensity. So after calculating this intensity, we shift one pixel and we calculate another. So after we calculate all the result that after we applying that 3x3 convolution mask, we can create a new image. So this is a result of image after applying Gaussian blur. So this is Gaussian blur. So median blur is a little bit different, and median means, for example, in this sample code, they use 11 corner. So they create 11, that is quite a big. One, two, three, four, five, 6, 7, 8, 9, 10, 11. This is a window. It is a mask. So it apply to original image, and they read each intensity value, and they sort intensity value, the lowest intensity value to highest intensity value. Then they take the center value to here. So then they shift one pixel to here and take another one. So that is a median blur. So if there are some spike here, the noise, so that will be the brightest part. So by taking the median of this the center value of the out of the 11 value, so we can eliminate the this kind of noise. So this is a median blur. So let's look at this example code, and they make a image, math image, and data 1, data 2, and we apply the Gaussian blur. So this is input image, and this is output image, data 1. We apply the 7x7 mask. This is quite big mask, and after applying mask, and they take only calculate only one number, and we apply the number here. So we can get this result, and we create a median blur. We apply the median blur. That result is data 2. So we create 11. We create a mask that have 11 element. Then we create a data 2. So this is image 2.jpg. So by applying Gaussian blur and the medium blur, we can create a new image that without the noises. OpenCV contains many useful and simple functions for applying linear algebra on image. Most major operators are allowed. When the image is given, that is a math image, and the image.inv inverse will provide the inverse of image matrix A inverse, and image.t is a transpose. You know what transpose is? This is A, B, C, D, E, F, G, H, I. If there is this matrix A transpose is this column become row A, D, G. This column become rows B, E, H, C, F, I. So this is a transpose. Image.clone create a deep copy of this image. So they create a clone matrix. Image.dialog, it returns diagonal. So in this matrix, diagonal is A, E, I. This vector is a diagonal vector. So image.mult, that is a multiplication, and math double. So it performs element-wise multiplication. Element-wise means this math is another matrix that has the same dimension of the image. So this is a piecewise element-wise multiplication. For example, IM image has A, B, C, D, and another matrix is 1, 2, 3, 4. Then image dot mul will produce 1A, 2B, 3C, 4D. So it is a piece element-wise multiplication. So this double is optional scale value. So default is 1. There is no scale change, but maybe we can scale up or down by setting the number. And this is different from operator star. So A star B is A, B, C, D, and 1, 2, 3, 4 is matrix multiplication. So this row and this column will be multiplied, and this row and this column will be multiplied, and it will create 4 by 4 2 by 2 matrices. So image dot cross will perform the cross product A cross product B, and image dot means A dot product B, and image dot I will create I is identity matrix. So 1, 1, 0, 0. So that is identity matrix. So it converts math to identity matrix. Singular value decomposition is a vital part of any computer vision based system. Luckily, OpenCV makes this trivial task. Trivial means a very easy task. To solve a least square problem, simply call solve command. This is a command. In order to explain this format, I need to explain least square problem first. When we imagine the system, you have some data from experiment. So that is x1, y1, xn, yn. You have many data set, and you want to create some linear relationship between x and y. So this is y equal ax plus b. Unknown is a and b. So by applying this data set to this equation, x1 a1 x1 equal plus b equal y1, ax2 plus b equal y2, so etc. So axn plus b equal yn. So you can turn it into the matrix form: x1, x2, xn, 1, 1, 1. Here is a and b. These two are unknown, and y1, y2, yn. So this is x unknown, this is a matrix equal b, ax equal b. It is a standard linear problem expression. So in order to solve this equation, you need to take a inverse. So by taking a inverse and multiply b, then you can get the x-axis. You can solve this problem. But problem is a is not square matrix. There is a n by 2 matrix. So in order to solve this problem, you multiply a transpose on both sides. Then it becomes a square matrix. Then you can calculate the inverse. That is a transpose a inverse a transpose b. So that is a least square method. Okay, so the solve means source 1, source 2, destination. Source 1 is a, this a, and source 2 is b. Destination is the x, the answer. The flag is method. So decomposition, LU decomposition and the decomposition SVD. So there are two method and other available method. So these two are the most popular one. LU decomposition is fast but cannot solve overdetermined system. So decomposition SVD can solve just about everything. Okay, so this is better. Okay, so example, you have 3 equation, but we have only 2 unknown. So that is a overdetermined least square problem. So in order to solve this one, we defined 3 by 3 metadata 1, 3 by 1 metadata. So in this example, we can express this equation using matrix form: -1, 1, 2, 2, 3, 2, -1, x and y equal 0, 7, 5. This is data 1, and this is data 2. But in this example they use 3 by 3 instead of 3 by 2. So we put 0, 0. This is a row, and here is a column. This is row, 3 row and 1 column. So we put the data into the data 1. We data 1 dot at float 0, 0. This value equal minus 11, and 0, 1, this one is 2, and 2, 3, and 2, 1. So we put this data 1 value, and we put matrix B 0, 7, 5 here. After assigning the data to the matrix A and B, then by calling solve data 1, data 2 result and decomposition SVD, then we can get the result. That is answer. So it is quite simple. OpenCV provide the principal component analysis module, and we call it PCA. So you already study on the principal component analysis. That is to calculate eigenvector and the eigen number, eigenvalue for the given matrix A. If you have a matrix A, that can be the data gathered from the world, and we can get calculate eigenvector V and eigenvalue lambda using this equation. So A minus I lambda V equals 0. So by taking determinant of A minus I lambda equal 0, then we can calculate eigenvalue from this equation, and by applying this eigenvalue to this equation, we can calculate eigenvector. So what is meaning of eigenvalue and eigenvector? This graph, this image is taken from our textbook, page 170, figure 7-1. And if you have some data that has a two-dimensional data, xi and yi, this data can be expressed as a point, scattered point on xy world. So the purpose of PCA is reduce the dimension of this data. So the eigenvector is this axis E1 and E2. The axis E1 shows the most that has most wide distribution of the data, and eigenvector E2, axis E2 is the direction that has the narrowest distribution of the data. So by transforming this data to E1 and E2 axis, then we can get this data. So in order to this projection, the PCA provide the PC project function. Then this white dot data can be expressed using that can be projected to the one axis E1. So this is a characteristic of this data. So from here to here, this is lambda. So we can after we get the we can approximate this data by projecting to this point to the eigenvector. Then we can back project to the original graph. So PCA provide the back project routine. So this is a format to call the PCA subroutine. Met data is a vector, and it calculates mean of this value, and there is a flag PCA data as row. So if a data has row has its own data, for example x1 y1 x2 y2, this is data is a row. Or you can get x1 y1 x2 y2, this is PCA data as a column. So you can select the flag based on the way you make the A matrix. And the num comp is k value. K value means maximum dimension to retain. A matrix, your data has a very big dimension. For example, 5 dimension, but you can take only 3 out of that 5. Then you can select maximum dimension to retain. But 0 means all value retained. Okay. So default is 0. So if you don't use this number of comp, so that is default value is 0. The all value will be retained. In general, just pass the vector into data and the mean will be returned. Okay, this is return value. So if we have a vector, then we can project and back project from the vector. So that is PCA. Please visit our textbook to learn more on the PCA analysis. So this PCA routine can be used to recognize a human face. If you have many data of human face, so human face, the feature has a multidimensional data, and so you find out what is the most extinguished feature, so most important feature. So you can get several eigenvector and eigen value. Then based on that information, you can recognize a human face. So PCA can be the very important function of the OpenCV in AI. There is two important tips here. First is remember that images are read from files as 8-bit unsigned integer, AU or C1 or 8UC3. This is a grayscale and this is color. Even though we read that image file using 8-bit unsigned integer, in order to do complicated math operation, we should convert this image to 32-bit float point type. at 32FC1 or 32FC3. Then convert back to write file. So in calculation of a complicated algorithm, we should use 32 float format. Then in order to save that image, we should back to the 8UC1. Always remember that the row is your y coordinate. Here is a coordinate. This is x, y, and as increase the x value, the number of column increase, and as increase the y value, the number of row will be increased. So remember that row is your y coordinate and the column is your x coordinate. Size objects are called x, y. So size is x, y. X is column, this is row. While images are referred row, column. This is image coordinate. And there are many subtle things that will ruin your good code. So if you confuse between the axis and the point position, then you should ruin your code. So please don't confuse with these two different expressions. This is at the end of the first part of our lecture, and I will make another online lecture today, and I will give you someday. Bye bye.